Okay, in this video we're going to look at systems of inequalities. And we're first going to look at the case where you have one inequality. So let's suppose we want to look at the graph of x plus y less than or equal to 4. So keep in mind when they ask you for the graph, you're actually finding the solution set of the inequality. Okay, you're finding the solution set. And if there is a solution for these types of problems, generally it's going to be an infinite solution, because it's going to be some points on could be a half plane, could be the area inside a circle or outside a circle, or a parabola inside a parabola, outside the parabola, depending on the boundary. Okay, so here's one procedure you can use. If we have x plus y less than or equal to 4, what you do is make the inequality into an equation. So on the right here I have boundary, and I have x plus y is equal to 4. So the boundary for this one is a line. So basically your solution set is going to be either all points on one side of the line, either below the line if it's one like this that's slanted, or the points above the line. So what you have to do is select what is called a test point. Okay, a test point. So basically the test point can be any point that is above or below, in this case the line. That's your boundary. 0, 0 is always a good point because it's easy to substitute. So in this case I'm going to use 0, 0. That's my test point. And notice the test point in this case is below the line. So I want any point that is not on the boundary. Okay, could be above or below, but we don't want it on the boundary. Okay, so all you're going to do is go back to the inequality and replace the x by 0. So I put a 0 where the x is, put a 0 where the y is, so I'm using the point 0, 0. So if I do that, this leads me to the inequality 0 is less than or equal to 4. Now if that's a true statement, then you shade everything on the side where the test point is. If it comes out to a false statement, then you just go the opposite. So in this case the point 0, 0 is below the line or the boundary, so we simply shade everything below. So I'm just going to draw some lines here, but keep in mind what you do is you shade everything. So it's like a half plane here. It's an infinite region. Everything, remember the line extends to infinity, and then we're shading everything below the line. So that's an infinite set. So I'm just going to label this as my solution set. So in this case my solution set S is everything below the line, including the line. Okay, because what I want here is I want to solve x plus y less than or equal to 4. So I want all points x and y such that x plus y is either equal to 4 or less than 4. Okay, well the points that make this inequality, this expression x plus y less than 4, are the points where the test point is, which are those points below the line, and the ones that make it equal to 4 are the points on the line. So here's the way it works. If you have an equals under the inequality, less than or greater than, then the boundary is included, so it's going to be a solid boundary. If you don't have the equals, everything works the same. The only thing is you're going to have a broken or dotted boundary, meaning that the boundary is not included. Okay, so in this case you shade everything below the line. Okay, we'll go to the next one. And here I have x squared plus y squared less than 25. Okay, the boundary then is x squared plus y squared is equal to 25. You should recognize that as a circle with center at the origin, that is 0, 0, and the radius is 5. Remember, the equation of a circle with center at the origin is x squared plus y squared is equal to r squared, where r is the radius. So in this case, if I rewrite the 25, I'd write it as 5 squared. So r is equal to 5. Okay, so here I have the circle then, and its radius 5. So in this type of situation, your solution set is either going to be everything inside the circle or everything outside the circle. The boundary is not included because I don't have the equals on the main inequality. So that's why I have it as a dotted. So again, if I use my test point 0, 0, which is inside the circle, plug it in over here, 0 where the x is, 0 where the y is, that would give me 0 is less than 25. That is a true statement. So that means that the test point works. So that means that everything in that area is going to work. That is everything inside the circle. So in this case, you shade everything inside. Now, had this been greater than 25 here instead of less than, everything's the same, except now this would read 0 is greater than 25, which would be false. So in that case, you would simply shade everything outside the circle. But in this case, we shade everything inside. Okay, so I'm just going to draw some lines. Don't want to take the time to shade everything, but you would shade everything in here. Okay, everything would be shaded inside. So I'm just going to label that as S. That's my solution set. Solution set for this inequality, again, is everything inside the circle, not including the points on the circle. Okay, so this is the way you handle those problems where you have one inequality. If you have two or more, it basically works the same way. You have to do each one individually and look at the common region. So in this case, I have a system of 2, and in this case they're first degree, so these are lines. The boundaries are going to be lines. So the first inequality, if I were to graph it, I would find 2 points. Okay, so I'm going to use the intercept. So I'm going to say, okay, if x is 0, the boundary, I'm not going to write it out, but it'll be x plus y is equal to 3 for the first one, and then the second one, 4x plus y is equal to 12. Okay, so just to save some time and space, I'll do it that way. So if x is equal to 0, I'm looking at the equation or the boundary, then y would be 3. Okay, going back the other way, if I let y be 0, looking at the equation again, or the boundary, then x is equal to 3. So since I'm dealing with boundaries that are lines, 2 points is all I need. Okay, so I come back over here to the graph. So 0, 3, so let's say I go 3 units and I get this point right there. And then 3, 0, I go 3 units to the right here, I get that point right there. Okay, so the line labeled as 1 represents the boundary for the first inequality. Okay, so then I had to decide for that one, what region would I shade? Again, either above or below. Well, if I select the point 0, 0 as my test point, I would get 0 is less than or equal to 3. That would give me a true statement. So that means for the first boundary, I would shade below the line. So I'm just going to indicate this with just going a little bit of shading, because I want this solution set for the whole thing. So if I was just given the first, inequality, I have the line, I would just shade everything below line 1. That would be it. And notice, because I have equals, the boundary is included. So these are solid boundaries. Okay. Now for the second one, again, I'm going to use some points. I'm going to use the intercepts. So I'm going to find the intercepts, the x and the y-intercepts. So I'm going to let x be 0. So if x is 0, again, I'm looking at 4x plus y equal to 12. That's your boundary. Then y would be 12. Okay, so that line would pass through the point 0, 12. Now if the y is 0, then now we get 4x equal to 12, x would be 3. So this would be 3, 0. Okay, so I would go then start at 0, 12, so up here start at the origin and then go 12 units up. So let's say that point right there is 0, 12 on line 2. And then I would go 3, 0, so that would intersect right here with the other one. Okay, so again, test point of 0, 0 would come out with 0 less than or equal to 12 for the inequality, so that is true. So for the line 2, I would shade to the left or below it. So this would go like this. Okay, so if I was given just the second inequality, I would simply shade everything below line number 2. That would be my solution. But in this case, I'm graphing a system, or if you want, I'm solving a system of inequalities. So in this case, I want the common solution. So in other words, I want to shade then only the region that is below line 1 and at the same time below line 2. So everything below line 1, okay, that's this part right here, but at the same time it has to be below line number 2. So if I were to extend the portions that I have there, the intersection would fall. Let me clear this. The intersection then would cover this area here, so it'd be everything below here. So this would be shaded for the final solution set. This would be shaded, this would be shaded, this would be shaded. So it's everything right in there. And remember, it's infinite. Okay, so this is just a portion of what the whole solution would be. Okay, because I want the region that's below boundary 2 at the same time below boundary 1. Okay, this portion right in here is not below boundary 2, so that one is not shaded. Okay, it has to be common to both. So that's my solution set. So I'll label this area right in here as S. That's everything shaded. Okay, let's clear this. And let's clear the next one. Okay, so in this case, the boundary for the first inequality is x squared plus y squared is equal to 64. That's a circle with radius 8. Remember, 8 squared is equal to 64. So here on the right, I have a circle drawn, a center at the origin with radius 8. Okay, there it is. Now the second inequality is a boundary line. So it's a line, the boundary is a line, x plus y equal to 8. So if I find, again, the intercepts, let x be 0, then y would be 8. So I come over here, 0, and then 8 up, so that's going to be right there, intersecting the line. Then if y is 0, x will equal to 8. So I come over here to the right, 8 units. So it's going to look like that. Now again, the test point that I'm going to use is 0, 0. Remember, you can use any test point. I can use 1, 0, I can use 1, 2. Any point, as long as it's not on the boundary. So 0, 0 falls inside the circle, it's not on the circle, it's not in the line. So now I'm just going to do this. For the first inequality, using the test point 0, 0, I would get 0 less than or equal to 64, replacing the x by 0, the y by 0. 0 less than or equal to 64 is true. So I'm shading everything inside the circle. Okay, so everything inside the circle would be shaded. For the second one, if I use again the test point 0, 0, replacing the x and the y by 0, I get 0 less than or equal to 8. That's true. Okay, so since the test point falls below the line, then I want to shade below the line. So for your solution set, I want the region that's common to both these two solution sets. So I want to shade then, for the final solution, I want to shade everything inside the circle that is also below the line. So notice this little region right here, that is not below the line. It's inside the circle, but it's not below the line. Okay, so that we don't want that. We want everything then in here. This region right in here, it's inside the circle, and it's below the line. So this is what I would label as my solution set, S. Now this is one way. This is one way to read the problems. Work the problems rather. There's other ways to do it, where you can look at the less than, whether it's less than or greater than, and determine it that way. But you have to be careful with that. with this method, if you follow this procedure, it's always going to work. So this concludes this video. Again, if you have questions or suggestions, please post them, and I will consider those, especially if you subscribe to the channel. And I hope these are helping you, and we'll see you in the next video.